All right, here we go, guys. We are going to solve the following by completing the square. Okay, so some of these might be factorable and we might be able to factor them, but because the directions say completing the square, we must do that process in order to get full credit. They also say express your answers in simplest radical form. So if we end up with a radical that can be simplified, we have to make sure that it is in lowest form before we box it up. Okay. All right, so remembering completing the square. Our job is to remember move C, pull A. Okay. And then our B term, remember, we're going to take half of that B term and square it. Okay, so that's what to do with the three variables in that exact order. So if we take a look, our A value here is 3, our B value here is 6, and our C value is 20. Well, technically it's negative 24. But what happens in this one, they made it actually, our first step is already finished for us. They already moved our C value over for us. Okay, so our job is to go ahead and pull A. And so we're going to go ahead and take that 3 and take it out of there. So that would become a 2x. Okay. All right, and so we pulled A from the left-hand side there. Okay. And so now this step here is finished. Okay, again, remember that you have to have an x squared term in order to complete the square. Okay, and right now we do. So now we're going to go ahead and do that whole completing the square. We're going to take our B value, which remember is always found next to your x term, and right now it's 2. What we do is we chop it in half, and we're going to get 1, and then we take that 1 and we square it, and which is also 1. Okay, and so now we're going to rewrite this, and we're going to insert that 1 that we just found. Okay. But we have to remember to add the same thing to the other side. And if you take a look, we actually added 3 to this side. So we're going to have to make sure that we add 3 to that side. Okay, so 3 times 1 is 3. And so we have to make sure that we add the 3 to our other side. Okay. All right, so what we created here is a perfect square trinomial. Okay. And we're going to factor it. So we're looking for numbers that multiply to 1 and at the same time add to 2, and they have to be the same number, and therefore it's got to be 1 and 1. 1 times 1 is 1, and 1 plus 1 is 2. And so it works in both. And so now we're going to go ahead and keep the 3 there, but we're going to take this easy trinomial and factor it into x plus 1 and x plus 1. We're also going to clean up the other side to 27. Okay. Because they are the same factor, we're going to write it as x plus 1 all squared. Okay. And we're getting closer. All right. Now, after we completed the square, we have that binomial squared. We are ready to go ahead and solve for x. And so our first step is to divide by 3. And we end up with x plus 1 all squared equal to 9. Okay. Now we're going to go ahead and take the square root. And you're going to remember that you're taking an even root of both sides. And so we have to remember that plus minus sign. And the square root of 9 is actually perfect. It's equal to 3. Okay. And then we're going to go ahead and subtract 1. And we end up with x equals negative 1 plus or minus 3. And because we don't have any square roots in here, we're actually going to separate our roots. All right, so we have x equals negative 1 plus 3, which turns out to be a 2. And we also have x equals negative 1 minus 3, which turns out to be a negative 4. And we found our roots or our zeros to our quadratic. And because they actually turned out rational, this tells me that the original trinomial could have been factored. We did not have to complete the process, complete the square to figure out what our roots were. We could have factored this one, but because the directions did say complete the square, that's why we had to do it this way. All right, so a lot to remember. So we're going to keep practicing and make sure that it gets embedded into our brains. All right, so again, number 2, we're going to complete the square. And your job is to remember move C, pull A, take your B, half it, and square it. Okay, so let's go ahead and say, all right, move C. Our C value right now is 4, and it's got to go to the right-hand side. And so we're going to go ahead and say 2x squared minus 12x equals a negative 4. Now that C is moved, we're going to pull A from the left-hand side. And our A value is 2, so we're going to pull the 2 out and be left with x squared minus 6x equals negative 4. Okay. And now we're going to go ahead and take our B value, which is always next to our x term, and so it's negative 6. We're going to cut it in half to get negative 3, and then we're going to take it and square it to get 9. Okay. Now we're going to insert it. So everything stays the same, except right here, we put that plus 9. And we got to remember to add it to the other side. However, you got to take a look and see what you actually added. All right. We actually added 2 times 9, which is 18. And so we'll be adding 18 to our other side. Okay. Now what we formed was a perfect square trinomial. And so off to the side, we're looking for numbers that multiply to 9 and at the same time add to negative 6. And you're going to find them to be the same number, which they have to be. Negative 3 and negative 3 multiplied give you 9, and negative 3 plus negative 3 adds to give you negative 6. So they work. So that usually tells me I'm good up until this point. Okay. So now we're going to take that easy trinomial and we'll factor it into x minus 3 and x minus 3. We're also going to clean up this side. Negative 4 plus 18 is 14. Okay. Because this is the same binomial all squared, we're going to now square it. Okay. All right. Now that we have our binomial squared, our job is now to remember to solve. So we're going to go ahead and solve for x. So we're going to divide by 2. And we end up with x minus 3 all squared equal to a 7. Okay. Now we're going to go ahead and square root both sides to get rid of the square. And when we do that, you have to remember that even rooting both sides of an equation means you have 2 answers. So we have plus, minus, and square root of 7, guys, is not perfect. So it's going to stay square root of 7, unlike the square root of 9 that we had in the last problem. One last step, we're going to go ahead and add 3. And remember, adding that 3 goes right in between the equal sign and the plus minus. And so we'll end up with x equals 3 plus or minus the square root of 7. And there are our 2 answers. If you want to separate them, you can. You do not have to, though. So we have 3 plus the square root of 7 and 3 minus the square root of 7 as our 2 answers. Okay. If you wanted to know what kind of decimals those are equivalent to, you can type them individually into your calculator to see the decimal that they would be equal to, so you can have an idea of where this equation would cross your x-axis. Okay. All right, let's take a look at a couple more. Okay. Number 3. So remember our steps, right? We can write them down just one more time. Remember that it's move C, pull A, take your B, take half of it, and then square it. Okay, in that order. So right now our equation in number 3 is a little funky there. We can see that we have our square term, it's positive, which we like. Okay, and we'll keep that there. But our 6x needs to come back over. But 31 can stay on that side because that's the C value. So now we are good. We got our 2 terms, our square term and our x term on the left-hand side and our C value on the right-hand side. So now the first step of moving C is done. Okay. Now we're going to pull A, except A is 1, and therefore we don't have to pull it. We have our square term, which means we're in good shape of completing the square because you can't complete the square without just having that squared term. So we're good. So we're ready to go ahead and do our B work. So our B value is negative 6. We're going to cut it in half to get negative 3, and then we're going to take it and we're going to square it, and we're getting 9. Okay. And so now we have x squared minus 6x plus 9. Okay. Equal to 31 and plus 9, because we didn't pull anything out, so we really only added 9 to the left-hand side, so only add 9 to the right-hand side. Okay. We just formed a perfect square trinomial by putting that 9 there, and so now we're going to go ahead and find our numbers. Multiply to 9 and add to negative 6. I feel like we just had this in the last one, I think. Negative 3 and negative 3 will do the job of multiplying to 9 and adding to negative 6. And so now we'll go ahead and factor our easy trinomial into x minus 3 and x minus 3. And we'll clean up the side. 31 and 9 make 40. And we're going to write this as one binomial, all squared. And then we can go ahead and solve for x now that it's a binomial squared. We square root both sides. Those cancel out, leaving me with just an x minus 3 on the side. Okay, technically I don't need those parentheses. You can keep them if you want, but you don't need them. Okay. On the left hand, we have to remember the plus minus, and then we have the square root of 40. Okay. We're going to go ahead and add 3 over, and when we do, it goes right in between the equal sign and the plus minus sign. Okay. And we end up with x equals 3 plus or minus the square root of 40. And we would be finished except directions, if you remember, said simplest radical form, and 40 is not simplest. There is a perfect square that goes into 40, and that is 4, and the other number being 10. And the square root of 4 is 2, and so we end up with 2 square root of 10. And so we have to replace that with 2 square root of 10, and then we can box up our answer. So we'll say x equals 3 plus or minus 2 square root of 10. And we can leave our answer like that, or you can separate them into 3 plus 2 square root of 10 and 3 minus 2 square root of 10. It's up to you. Okay? We'll just write them down just so you know. That would be one of your x equals, okay? And then your other one would be this. All right, but again, you don't have to separate them unless you want to. All right, guys, let's take a look at number 4. Okay. Again, we have to remember our steps, okay? And we really don't care for a negative square term, so I'm actually going to move that back over. So I'm going to go ahead and add 4x squared to the other side, so it would be a 4x squared. And when I add it over, it'll be on the same side as the 24x. Okay. However, I want the 11 to go over there, and so I'm going to say equals negative 11. All right, so now I have my two terms on my left-hand side, my squared term and my x term. Okay? And then I have my c value on the other hand side. All right, so a little bit tricky to rearrange that. Just make sure you double check things. Okay, so now that c is over, we're ready to go ahead and pull a. So our a value is 4, and it's going to come out, and it's going to be x squared plus 6x equals negative 11. Okay. All right, now we're ready to do our b work. So we're going to take our b, which right now is 6, cut it in half, which is 3, and square it and get 9 again. Okay. And so we'll keep the 4. This will be our x squared plus our 6x. Our plus 9 will go here. Okay. Equal to our negative 11. And then just double check, what did you really add over here? You actually added 36. So we'll add 36 over there. Okay. All right, what we just completed was the square, and so now we have a perfect square trinomial. And so our multiply is 9, and our add is 6, and 3 and 3 this time will do the job. So we'll go ahead and factor our easy trinomial into x plus 3 and x plus 3, and will be equal to negative 11 plus 36, which is 25. Okay. All right, because it's the same binomial, multiplied by itself, we can write it like this instead. Okay. And now that we have our binomial squared, we're ready to solve for x. So first thing is we're going to get to divide by 4. And we're going to end up with x plus 3 all squared equals 25 over 4. Okay. Then we're going to go ahead and square root both sides. Okay. And we're going to end up with x plus 3 over here. On this side, we have to remember the plus minus, and 25 is perfect, and so is 4. So if we take the square root of 25, 4, so we're really just taking the square root of 25, which is 5, and the square root of 4, which is 2. Okay, and then one last step, we're going to go ahead and subtract 3, and I'll come up here, and we say x equals negative 3 plus or minus 5 over 2. And because there's no radicals in there, we can actually go one step further and separate these, okay? We could say negative 3 plus 5 halves, which is really 2.5, okay? Gives us an x value equal to negative 1/2. And that's one of our answers. And if we separate this, this would be negative 3 minus 5 halves, which would give me an x value equal to negative 11 halves. Okay. Or you can also say negative 0.5 and negative 5.5 if you'd rather. And because those are actually rational, that tells me that this original equation could have been factored. All right. Unlike in number 3, where we have that square root of 10, that could not have been factored. That's irrational. All right. But because these are rational real roots, we could have factored this one. All right. We got 2 more examples. Hopefully we're getting the hang of things. Okay. Again, I'll write down our directions. Okay. More time we write them down. Hopefully that helps. But move C, pull A. Take B, take half, and then square it. Okay. And so in number 5, it's a little goofy. We got those parentheses, so we're going to have to go ahead and distribute, and we would end up with 4x squared plus 16x equals 3. And if you take a look by doing that, our C is already over there, so first step is finished, but we do have to pull A. So we're going to go ahead and take out the 4 now. I guess we could have really just distributed the x and then we would have been good, but a little tricky. All right, so taking out the 4, we'll have x squared plus 4x still left inside equal to 3. Okay. And now we're ready to do our B work. So we're going to take B off to the side, which is 4, chop them in half to get 2, and then square it to get 4. So this is all going to stay. And that plus 4 is going to go right here. And we have to make sure that what we did really add to the other side, we actually added not 4, but 16. So we have to have a plus 16 here. Okay. All right, we're ready to go ahead and take our perfect square trinomial and factor it. And so we're going to find numbers that multiply to 4 and at the same time add to 4. And so it's got to be 2 and 2. Okay. So this 4 will stay. Our easy trinomial will get factored into x plus 2 and x plus 2. And we're equal to 16 plus 3, which is 19. Because it's the same binomial times itself, we can write it as a binomial all squared. And now that we have that binomial all squared, we're ready to go ahead and solve for x. So first thing I have to do is divide by 4. And we end up with x plus 2 all squared equal to 19 fourths. We're going to leave it like that. We'll square root both sides to get rid of the square. And we're left with x plus 2 equal to a plus or minus. Now, square root of 19 is not perfect, but the square root of 4 is. So we're going to leave the square root around the top number with 19, but the square root of 4 just becomes 2. Okay? One last step, we're going to go ahead and subtract that 2, and remember it goes right in between the equal sign and the plus minus. So we're going to say x equals negative 2 plus or minus the square root of 19 over 2. And the square root of 19 is actually perfect. I'm sorry, not perfect, but not, it's definitely not perfect, but it can't be simplified. Okay? There's no perfect square that goes into is what I meant to say. And so we're going to leave it like that. Okay? If you want to separate your answers, you could say x equals negative 2 plus the square root of 19 over 2 is one of your roots. And x equals negative 2 minus the square root of 19 over 2 is your second root. Okay? And there are your 2 irrational but real roots, okay, or x-intercepts. All right, last one. All right, remember our directions. Move C, pull A, take your B, take half and square it, okay? So taking a look, we are equal to 0, and so we're going to go ahead and move our C value over. So we'll have 4x squared minus 4x equal to a 47. We'll pull our A out, which is 4, and be left with x squared minus 2x equals 47. Okay. Nope, not a 2x, a 1x. Excuse me. All right, so that's just minus x. All right, we can check our math. Yep. Okay. All right, so now we're going to go ahead and take our b value off to the side, which is actually a negative 1. We're going to take half of it, which is negative 1/2, and then we're going to square it and get 1/4, positive 1/4. So this is why we save this one for last with that fraction in there. But fractions are numbers too. Shouldn't really change a whole lot. Just make us think a little bit harder. All right, but that's a plus 1/4 in there now. Equal to a 47, and now we got to check what did we actually multiply this side by, or add to that side. We have a 1/4 times a 4, which is a positive 1. Okay. And now that we completed the square here, we should be able to factor it, which a lot of people are like, oh my goodness. We're going to multiply to 1/4, yep, and add to negative 1. And the numbers that are going to do the job are 1/2 and 1/2. Negative 1/2 and negative 1/2. All right, so if you multiply two negative 1/2s together, you'll get a positive 1/4 for your multiply, And if you take -1/2 and you add -1/2, you're going to get -1 for your add. So a little bit tough, but if you've been following the little procedure here, you can kind of see that the numbers that you find that do the job for your multiply and your add are always half of that add number. Okay, so I don't know if that is a good little trick to figure things out. Okay. But we don't see these fractional ones very often either. All right, so we're going to go ahead and we're going to factor that easy trinomial now that we found the numbers into x minus 1/2 and x minus 1/2 equal to, on this side, 48. We're going to go ahead and write it as a binomial squared so that we can get on with our solving for x process. Okay. Now we can solve for x. First step is to divide by 4. And we get 12. Okay. Then we're going to go ahead and square root both sides. And the square root will cancel each other out, leaving you with an x minus 1/2 equal to, don't forget the plus minus, square root of 12. Okay. Then we'll go ahead and add our 1/2 over. And don't forget, when we add it over, it goes right in between that equal sign and plus minus sign. Okay. And so I'll come over here. X equals 1/2 plus or minus the square root of 12. And it'd be finished except directions say simplest radical form, and 12 is not in simplest radical form. Square root of 4 times the square root of 3 is how you break it down, and then the square root of 4 becomes 2 square root of 3. So now we have to rewrite it with that replaced. So we'll say x equals 1/2 plus or minus 2 square root of 3, and that would be simplest radical form. And there would be our two answers, okay? Our roots would be real but irrational. And again, if you want to separate them, you can, okay? One of them would be 1/2 plus 2 square root of 3, and the other one would be 1/2 minus 2 square root of 3. And if you wanted to see what decimals those are equivalent to, you could go ahead and type them into your calculator, okay? Or you can leave them together with the plus minus sign. All right, so that's completing the square. Kind of a lot of algebra going on. All right, so it takes a lot of practice to make sure that you get the procedure down and accurate. Okay. All right, I will see you guys on the next day of notes.